We have two people to introduce, both directors at Capital One. We have Carrie, who is the director of threat hunting, and David, the director of security chaos engineering, which sounds like a very interesting job title. David even, and I'm going to share a small secret, David shared in the instructor channel, the secret one, that he even got dressed for this presentation. So I'm very excited. I'm very impressed. So I'm very honored as well. So without further ado, kick it off, and I'm looking forward to this one. Thanks.
So thank you. And I want to open this up with an apology. So I'm known for making some of the most achingly painful, boring slide decks around, and when people would feel physical pain when they see my decks. So I was issued a challenge, and the challenge was to be funnier or use amusing graphics or references to Doctor Who. I was going to try that, but I don't really like DC comic book hero movies, so this is what you get. I'm sorry. So that is me. I do security chaos engineering. I'm on the left. The best thing from here is actually starting the indoor snowball fight in Las Vegas. That was in 2007. I grabbed some snow, I took it inside, and I hit my boss with a snowball. That is pretty much the most exciting thing that I've ever done in my entire life.
All right, guys. Hi, I'm Carrie. I am the lead threat huntress at Capital One. I have kind of, I guess, a diverse background in security, but started off at Georgia Tech in international affairs, continued at Georgia Tech for my master's in computer science, and I love talking about anything related to threat intelligence and Russian language, cultural politics, or cybersecurity policy is also awesome. So today we're going to talk to you guys about threat hunting and how we can use security chaos engineering outputs in order to create a hunt hypothesis. So we're going to kind of set the stage, explain kind of why creating hunt hypotheses can be kind of challenging and some of the things to consider when you're doing it. David's going to give us an overview of security chaos engineering and what it is and what, how he does what he does. We'll talk about the kind of data that we get from security chaos engineering tests, and then also walk through how to apply that to a hunt. So first, I wanted to kind of start us off by talking about what makes a good hunt hypothesis. And this is kind of, I kind of think about it in terms of like the real world and then the ideal world. Now, the scale between, the transition between real world and ideal world, ideal is relative to everybody. It's different for everybody, and it's different in every organization you're going to be in. But what I typically find is that when we're doing initiating a threat hunt, there are a couple things that kind of themes that typically come out of these very commonly. And so most of the time, it's really kind of a little bit more of an art than it is a science, right? Some of the time, sometimes it's just an analyst was reading an article and got curious, and that's awesome because curiosity is a cornerstone of threat hunting. So that is super great when that works out. Some of the other ones I get are an executive read a news article and got curious, which is a little bit it's not quite the time you want to be threat hunting necessarily, but it's something that actually comes up pretty frequently that in my experience. Sometimes I don't know how many people have had this experience themselves, but I have certainly been just kind of goofing around in the logs and stumbled across something and then pretended like retroactively that I was looking for that thing all along. So, definitely not saying that that's happened, but it's totally happened. And then some of the other things too, where, sometimes you get data from like an incident response investigation, or sometimes you just have a hunch. Or, you shook a magic 8-ball and that's what came out, right? But in the ideal world, like as you start to kind of have to mature your program beyond that kind of curiosity-based or kind of intuition-based hunting, there are kind of a couple things that typically you want to kind of maximize for your hunt when you're creating your hunt hypothesis. So the first is that you want to maximize your chances of actually finding a threat actor. And again, that's specific to your environment, and what's specific to, your organization, your environment, all that kind of stuff. But what, you want to make sure that you're kind of setting yourself up for success as much as possible to find a threat actor. And then related to that is you also want to make sure that your hypothesis is in some ways broad enough that even if that threat actor isn't active, the thing you're looking for isn't present in your environment, you're still likely to find something, those like secondary benefits that come out of hunting, whether it's gaps in logging invisibility, or, those kind of something interesting, bad security practices that happen in the organization, something that would kind of help ensure that you have those secondary benefits to show at the end of a hunt operation. And then you also want to make sure that it's narrow enough so that when you have results, you know how to interpret them and you know what you're looking at. So the kind of the canonical example that I like to use and that I'll use here throughout this presentation is actors performing command and control over web protocols. We all know this checks all those three boxes, right? We all know that actors, in the majority of cases, have to perform some kind of command and control. And command and control over HTTP or HTTPS is more and more common because it works, right? The other thing too is we know, if we kind of expand that out, you've got your hypothesis and then your detection strategy, how you're going to look for that. So in this case, right, like I can't tell you how many times I've seen somebody say, oh, easy, we'll look for beaconing, myself included. And so what you find when you do that is everything beacons, right? It's not just malware. Lots and lots and lots of things beacon. But it kind of raises the question as you're looking through that data and seeing all these things that are beaconing, it kind of raises this question of like, should all these things actually be beaconing? Is that normal or appropriate for our environment? So you end up learning a lot about your environment just from the act of hunting. And that's always like a secondary benefit that you want to get. And then finally, checking that third box by narrowing down to beaconing, you bound your results. So you know what you're looking for and you know kind of how to interpret the things that you find. But that's not all of it, right? For anybody who's ever tried this, you know that like there are so many different things that actors can do to kind of impact how you hunt or how effective your detection strategy is for detecting beaconing. And so, that can be by manipulating like the domain to make it look like a false positive, using something like domain fronting or using jitter to affect how your beaconing detection works in practice, right? And whether it detects or not. So these are all things that you have to kind of think about or kind of tailor like in practice when you actually go to execute your hunt, that you have to kind of figure out, well, what am I going to account for as part of this hunt and what am I not going to account for? So going back to this first slide, right, to move things even further from art into science, there are three additional things that I typically like to layer on when I'm thinking about a hunt hypothesis. And so the first is that you really want to cater your hunt to where you know that you have logging and visibility, because if you don't have logging or you don't have visibility, you're kind of setting yourself up for failure from the start, right? So you want to make sure that you have logging. And then the second piece is you want to hunt where you don't already have preventative controls, because if you're already preventing it, you don't have to, you don't necessarily have to have a human going out and proactively looking for it. And same with detective, right? Like if it's already being detected in your environment, it's probably going through a different pipeline for triage and analysis. So again, it's not necessarily the place that you'd want to direct your hunting resources. So that raises the question, how do you find these gaps in the first place? And that's an excellent question that Laveza is going to answer now.
I'm so glad that I have the answer totally off the top of my head. And the answer is a question. The question is, what is security chaos engineering? So as a side note, I look at this whole process a little bit differently. Rather than focusing on detection and adversarial simulation, I'm taking a step back and looking for the performance of the tooling itself as it exists in real life. So detecting adversaries isn't really what I'm concerned about. I'm concerned about the observability, measurement, and repeatability of what we're doing. If it detects, great. If it doesn't, great. What matters is that we're establishing the baseline, something to build the rest of the program off of. So I want to know when things change over time, if the tooling that is responsible for driving detection strays from the expected result. So the chaos in security chaos engineering isn't the experimentation being performed. It's the BAU, the business as usual work that happens every day. So it's not about breaking things, it's about fixing things. So like attacking, like that sounds like it's a red team. It's like, well, in some cases it can be. So we're taking attacks that you see in real life and applying it to your own environment in order to understand what your defenses actually look like. But these outputs, isn't that purple? Well, yeah, maybe, but I'm still not really concerned about the detection coverage. The focus is going a bit higher. So looking at the tooling itself that allows the detections to manifest themselves and really help out the teams who are dedicated to doing the actual hard work, the defense in the enterprise. But yes, it is blue, but they've got enough problems to worry about. So the focal point is helping answer the question of, are these critical alerts quiet because we're not being attacked, or is it because the alert is broken? So we get back to here. I actually did this myself, so I feel like I'm pretty talented. So building off of the traditional chaos engineering, you will start with a hypothesis of what do you think will happen? Are you correct? What you find at this stage is where you really start building the baseline of what you can prove. And again, I'm not really concerned about detecting threat actor techniques that have been reused across thousands of times because security is fundamentally broken, but I'm concerned with the gaps that are there due to deficiencies. And we discover these deficiencies through experimentation. So typically you'd use framework of some sort that everyone's going to be familiar with: Atomic Red Team, Scythe, Prelude, Caldera, or one of the 500,000 vendors trying to bum rush the space. So then we do it. So if this technique was performed, do we see it? Where do we see it? We're looking for defense in depth and detection in depth. We want to be able to prove with data that the defensive strategy that's been designed actually works. So the experiment's launched. So when the first time you do it, whatever the results are, this is good or bad, it's going to be the baseline. If you've never done this, this is really, really, really time consuming. So identifying baseline behavior is pretty much the most difficult part of the entire process. So once you get to there, it is repeat forever. Automation is really the only way to stay sane, because if you don't automate, you are going to lose your mind from data analysis. I have done that. Carrie can attest. So let your mind rest at this stage. So like you would run it weekly, daily, whatever. A goal is to ensure that the changes are identified early on before a cascading failure can happen. So it's kind of like eating soup. You don't just smash your face into the bowl and hope for the best. Like you're going to test a small portion of it to make sure it's the right temperature, it's the actual soup that you ordered. Or maybe you don't. I'm not going to judge people for how they eat. So the goal is to understand how these tools work together, if they're functioning as expected. As you experiment and identify the deviations, this drives the engineering teams to improve the platform, which feeds detection, which tells everybody where gaps exist. Automation is required because you do it forever, because failure is the normal condition, and there will always be gaps in understanding. And how do these gaps happen? They happen through regular work. So despite the name, security chaos engineering doesn't generate the chaos. It comes from the tuning, the updating, the lack of updating, the regular work that people do every day. So we're here to help fix, and the gaps typically start small, like little temporary fixes as a compensating control that turns permanent, stopgap solution, things like that. Something to fix later that never gets fixed. And then years later, because teams have so much to do and there's so few people, you have considerations. You get competing priorities. You make changes in response to audits, changes required to check the compliance box, team reorgs, strategy changes, duplicative tooling, lead engineers leaving for Oracle, DNS, expired certs, or me trying to do work. So many of the problems that we see aren't from advanced attackers. It's organizations struggling to keep up with their complex environments. So now that we identify gaps in our layer's defense, what do you do next? So here we start with a hypothesis that we mentioned earlier. So you start building on your concerns. If X happened to us, would we see it? What tools do we have that provide the visibility of an actor doing Y, and does that tooling actually work? This is where, in my opinion, the difference between detection pipelines in purple and security chaos engineering start to grow. So in the example here, we expect to see UAC abuse, account discovery, C2, interpretive dance, lateral movement, and more. But do we? Like, do we see events for application control? Do we see the proxy events, firewall events, events forward logging? If we do, great. If we don't, then we know where we have holes in our understanding. So the big key to all of this is automation. So testing it this one time never gives a complete picture of how your systems perform over time, and it needs to be done regularly in order to catch deviations before they're taken advantage of, because you can't really map and measure threats if you don't have the necessary data.
Awesome. So in practice, what this looks like, you need a couple things before you start hunting to make this work. So the first is to understand your network architecture. And so really what you want to just understand is where do all of your detection or detective and preventative controls sit relative to one another, because it'll help you understand how to interpret the testing that your security chaos engineering team is doing. And then the other thing is the list of automated testing. And so I have a couple of toy examples here that are similar to what you would get, like something David would produce for me, right? And what this really is just the list of all the tests that your chaos engineering team has run and the results that come out of that, right? And so in this case, we're kind of focusing on variations of C2. So the first thing that we want to get from this is understanding where we have logging and where we don't. And so again, this is a toy example, but this is actually exactly how we produce the data, like how we basically take the data out and analyze it when we're setting up for a hunt. So what I have here is a heat map that shows basically our logging rates over the course of 5 months. And so what you want to do is you want to kind of start off by saying, okay, where do I know that I have logging? And so we're super lucky in our environment, our hypothetical environment. We have 100% visibility. We log every single time that David has produced a test. We've logged it. So we have logging there. It's not yet signal. It's not yet something that like an analyst would necessarily have already looked at, but we know that the logging, like the visibility that we need is there. The one exception to that in our hypothetical environment is SSL. Let's say hypothetically we didn't have any kind of SSL interception. And so we were, for the first part of the year, kind of blind to anything that was happening over HTTPS. So then the second thing that we want to see is prevention, right? And so ideally, like I said before, we want to be hunting in an area where we don't already have good prevention. And so if, for example, we know that we're always detecting payload downloads when they're over HTTP, because we have really good prevention for that, then we wouldn't necessarily want to be hunting for that. And so in this example, right, what this data is telling us is we actually don't have very good prevention. Our preventative controls are struggling to block C2 to resold domains. And so if the domain has like history, right, it's hard for us, or it's hard for our preventative controls. And then the other thing too that we're seeing here is that, again, right, as we implemented SSL interception, right, all of a sudden our prevention rates went up. And so that's really awesome. That can tell us as a hunter, or me as a huntress, like, when I should or shouldn't go and look in HTTPS data. And then we also saw something interesting here, which is another kind of thing that's really relevant when you're getting ready to set up for a hunt. we see that in April and May, we saw a drop off in our prevention rates for C2 when there are known bad hard-coded user agents. And so we don't yet know why that is, like what happened, but we know that there's something that we need to go and dig in there and maybe provide, potentially provide like a, compensating control until we get that back to working. So we can go to the next slide. So then the final thing is detection rates. And so this is where we're gonna like bring it all together in the next slide. But what we're seeing here is that we actually have, we have some alerting when we're going to resold domains, right? Or when we're seeing TRAT-C2 to resold domains, we have some alerting for that, but it's spotty. It's not always like 100% thing. We're not detecting 100% of it. And so that tells us, tells me as a huntress, right? Basically, I know that in the majority of cases in this example, alerting is going to a human analyst to look at. It is being detected, like there is signal that somebody can go and look at. And so I can assume that those things are being triaged through a different pipeline, through a CSOC, something like that, right? But I know that there is a gap in this resold domains kind of area. And so, so we put that all together, right? We now know in our based on our kind of high level hunt hypothesis and our detection strategy, what do we need to really account for, and what can we kind of pass over when we're doing when we're constructing our actual like analytic to detect this. We know that we don't have to account for payload downloads because we're good. It's detected, it's prevented, we're good. We probably shouldn't do a historical search in HTTPS communications, HTTPS logs, because we just don't have the logs to support them historically. We also know that as hunters, we shouldn't focus on like, you may have skipped over this, but there were a couple of tests around dynamic DNS or C2 directly to IP addresses, kind of bypassing DNS altogether. And in this situation, we know that we have effective detection and prevention, so we're good. We can skip over that as well. And we should really focus on the resold domains kind of angle. So that's just one way that the heat map and that kind of approach is one way that we use this data when we're constructing hunts. But there's a lot of different ways that you can slice and dice this to make it really meaningful depending on the use case that you have, right? We can and do measure this, use this to measure our effectiveness over whatever framework of choice you have, right? So MITRE ATT&CK is great, that's what we use, but you can use it again, whatever you want. Then the other thing is you can also use this like as a hunter, right, to get a sense of where we are leaning really heavily in terms of logging, detection, prevention, et cetera. And so you can say, oh, well, our proxy logs are really, really important, or our Windows event logs are really like, there's a lot of data in there for us to go and look at. So it can give you a sense of where you can lean, which data sources you can lean on more heavily versus not. And then also tracking progress over time, right? Like ideally, you want to be able to map benefits coming out of your hunts, the secondary benefits, increased prevention, increased detection, et cetera. You want to be able to map that. And so this gives you actually a way to kind of start to track that over time and to show that like you're helping to support growing your organization's defensive capabilities over time. And then the last thing, right, the last example would be using this to actually, kind of slicing it according to malware types or to threat actors. so that when you do have a question about, how protected are we against ransomware, you have an answer. You have a way to kind of, one, to say, well, we see either these are, our rates are good or bad. And then as a hunter or as a huntress, I would go through this to say, well, this is actually, if you want me to go hunt for ransomware, I'm going to hunt for these families or something along those lines.
So the benefits of doing all this is basically to understand how everything works in your production environment, because you always work in production. Don't let anyone tell you different. It's the best practice somewhere. It'll validates that your controls are actually effective, and importantly, it gives your leadership an idea of what the return on the investment of security is, because security is really, really expensive and not everybody's got tremendous budgets. So knowing that your tooling works, knowing that the stuff that they invest in is actually working, helps generate the buy-in needed to fund the position that you're already in, or the one that you're proposed of doing. And it helps measure the maturity of your program. It gives you defensive metrics and makes you enthusiastic about hunting. And that is it.